A straight wire of mass 200 gram and length 1.5 meter carries a current of 2 ampere. It is suspended in mid-air by a uniform magnetic field. Find the magnitude of magnetic field. Here, this is a conductor of length 1.5 meter. It is placed in a magnetic field. Here, cross represents the direction of magnetic field into the plane of the paper. Cross means the direction of magnetic field into the plane of the paper or board. Okay, so here this conductor of length 1.5 meter carrying current 2 ampere is placed in the magnetic field. We know that when a current carrying conductor is placed in external magnetic field, it experiences a force. Okay, so force experienced by the conductor is F equal to, we have the general formula BIL sin theta. Okay, so theta is the angle between length and magnetic field. Here length means in the direction of current and magnetic field. Here length and magnetic field or current and magnetic field are perpendicular, because cross means magnetic field is into this horizontally or towards x direction is the direction of current or direction of length. So theta is 90 degree, therefore force is given by BIL since theta is 90. Okay children, now what is the direction of this force? We can find out the direction of force by using Fleming's left hand rule. Here Fleming's left hand rule, magnetic field is into the plane of the paper. Direction of current is towards right. So what is the direction of force in which direction? Upward direction. So direction of force is towards upward direction. So here the direction of force is upward. Now if this conductor is placed in the magnetic field, it is suspended in mid-air. It is suspended in mid-air means it remains stationary in mid-air. So one force is acting in upward direction, so some other force may be acting in which direction? Downward direction. Then only that rod remains stationary or it is suspended in mid-air. Without any change or moving up or down, it remains stationary means one force is acting, that is the magnetic force is acting in upward direction. So what may be the other force which is acting in the downward direction? That is gravitational force. So gravitational force acting on the object is, or gravitational force or weight, gravitational force appears as weight. Weight acting on the conductor. We know weight is equal to mg, isn't it? Mass is given. What is the mass? Mass is 200 gram, no? Convert to kilogram. So 200 divided by 1000. We can take g as 9.8. G is acceleration due to gravity, which is 9.8. And what is its direction? The weight is always in the downward direction. Okay. So here the rod remains stationary means both the forces are equal and opposite. Okay, they are opposite. One is in the upward direction, another one in the downward direction. And if you equate the two magnitudes, we can find out the value of magnetic field. So we can equate the two force BIL equal to mg. BIL equal to mg. B into current, no, it is 2 ampere. Length is 1.5 meter is equal to m into g, that is 200 divided by 1000 into 9.8. Okay. So it can be simplified as B equals after simplification B into 2 into 1.5 equal to 200 by 1000 into 9.8. After simplification you will get 1.96 divided by 3. So it is 0.65 Tesla. So magnetic field is given by B equal to, we got the value of magnetic field as 0.65 Tesla. That's the answer. Loop shown in the figure. APB and AQB are semicircles. Find the magnetic field at the center C. So this is a current loop. Here I is the current entering, and current at the point, what happens to the current? Current splits into 2, isn't it? So what is this current? This is I by 2. This is I by 2, that we know. And at the point B, again it combines to form I. So what is the magnetic field at the center? This is center C. Due to the curve APB or semicircle APB, so magnetic field at C due to APB, that's a semicircle. We know magnetic field is equal to magnetic field at the center due to a circular loop is mu 0 I divided by 2R. Since it is a semicircle, it is mu 0 I divided by 4R. Okay, let R be the radius, 4R. But here what is the current flowing through the first semicircle arc, that is equal to I by 2, no? So mu 0 I by 2 into 4R. Similarly, that is, we know magnetic field at a point at the center of a circular loop is mu 0 I by 2R. For a semicircular loop it is mu 0 I divided by 4R. But here what is the current? I by 2, isn't it? So mu 0 I by 2 divided by 4R, that is mu 0 I divided by 8R. Similarly, magnetic field at the C, at the point C due to another loop AQB. Magnetic field at same point C due to AQB, that is also same, be equal to mu 0 I divided by 8R. Now what is the direction of that magnetic field? How will you find out the direction of magnetic field? If you consider APB, here the direction of current, this is the direction of current. So according to right hand thumb rule, the direction of magnetic field is into. So into the plane of paper, into the plane. Here AQB, here this is the direction of current, no? So what is the direction of magnetic field? Out of the plane, right? Out of the plane. Out of the plane of paper. Here also into the plane. Now, what is the net magnetic field? One magnetic field is into the plane and another one is out of the plane. So what is the net magnetic field? Net magnetic field is this one minus this one. So net magnetic field equal to 0. The magnitude wise both the magnetic fields are equal, but direction wise they are opposite, and hence net magnetic field equal to 0.